Now continuing from last visualization, in this I'm going to show the effect of unequal amplitudes and unequal frequencies. So first let us see about the amplitude. So what happens if the amplitude is changed? So presently the phase difference is 2 pi and amplitude is 1 for both of them, frequency is 1 for both of them. Let's see what happens if the amplitude is changed. Now amplitude A2 is 1.26 in this direction. You can see this is higher than this and the angle is changing. The angle depends on A2 and A1. So this is about 2.64. So motion always occurs in a rectangle of 2 into 2.64 and 2 into 1 on the x-axis. We can see this. So here again, if we change the phase, the effect would be same. We'll do a faster one. See, first it starts to bulge. Now here we'll not get a circle because A1 is not equal to A2. At 1.57 we get a ellipse. If A1 was equal to A2 we would have got a circle, but now it is an ellipse with y-axis. Now this continues until pi, where it becomes, here is the transition 3.14. It makes a obtuse angle with the x-axis. Three pi by 2. Three pi by 2, and again it continues. So whichever side the amplitude is higher, the ellipse would at 0 or at pi by 2 or 3 pi by 2, it makes that direction as a major axis. Let me put this back at 0 and let's go back to amplitude, some other amplitude, the highest possible in this visualization. Now let us see the case where x-axis amplitude is higher. So the x is minus 2 to 2, y is minus 1 to 1. We have a rectangle and the motion happens there. Let's see the special case of pi by 2. You see it's an ellipse with x-axis as the major axis because x amplitude is higher. Let's see at 3 pi by 2. It's a red ellipse, that is the rotation will be anti-clockwise. So now let us look at the case of unequal frequencies. For simplicity, let us keep the amplitude 1 for both of them. To start with, let us put the phases also same, and let's make the frequency of the Y oscillator as 2. Now let us see how this motion would look. First let me use the time slider. So at t equal to 0, both x equal to maximum and y is equal to maximum, so the combined effect would be here. So as the time passes, you can see by the time y is reaching its negative extreme, x would be reaching its mean position. This dashed line over here indicates that this is the point where this y is equal to -1 becomes a tangent to the combined path. So now here it becomes tangent, and as time passes, remember the frequency of second is double the first one, hence by the time the Y oscillator completes one oscillation, X oscillator will complete only half the oscillations. So it has gone and it is coming back, whereas X is going and reaching its left extreme. Somewhere like this. So you can see the path had gone like this. So how was the path? It is something like this. Presently we are here time wise, and it will retrace the path. So again going back also, it touches the same point, and this completes the one full cycle. Now let us see what happens if the phase of the Y oscillator is also changed. Let's make it something else. 1. So at t equal to 0. Now this two dashed line indicate that this y is equal to -1 line becomes tangent at these points. So when phase was equal to 0, tangent was here, because now it is starting here. By the time it reaches here, the x would have reached only until this point. Let us see. Now the y is almost reached. So when y has reached its minimum, x is here. So and again it continues like this. Let us trace it. When y is on the maximum, x is still to complete its journey towards its left extreme. So this will keep going this side. So this is the point at which x has reached its extremum. So and y has completed its one full oscillation. Now by the time it reaches the negative, x would have covered only this much of distance. So that's why the tangent is here. This is the second tangent. So if it forms a closed figure, the tangents can give us an idea about the ratio between the frequencies of the y and the x oscillation. Presently there are 2 for y and 1 for x. So the ratio is 2:1. Now as the initial phase increases, the starting point would come closer and closer to this point, and the point where tangent occurs will move towards the right. Now let us observe that by changing the phase. So this is with the 0, As the phase is increasing, the tangent points are shifting, one to the right and one to the left. Remember when frequencies were equal and amplitudes were equal at 1.57, that is pi by 2, something interesting happened. Here also we get the symmetric figure, and at x equal to 0 and y equal to 0, the object comes twice, once while going and once while coming back. Then after pi by 2, it's the same effect. The path appears to be going back to pi is equal to 0, but just inverted, and at phase difference of pi, there's an inversion of color. That means the sense of rotation has changed. Again, you can see the tangent points are moving this side, and this common point would come here at 3 pi by 2. So 4.71 is 3 pi by 2. So it's here. Let us observe the motion. So it goes here, touches the line. So it's minus. So it's extreme, positive extreme, and comes back to the x equal to 0, y equal to 0, reaches its minimum, a tangent forms. So it's a closed figure. So as we continue from 3 pi by 2 to 2 pi, we are getting the shape back of phase difference 0. So this is for phase difference of 2 pi, this is for phase difference of 0. Now let us see what happens if it is 3. Y frequency is 3 and x frequency is 1. And let's keep some initial phase and let us see what happens. You can see there are 3 points at which it will touch the y is equal to -1 line. So let's quickly draw that. So 3 times it has touched. This is how it goes. Second time it is touching. Again, when we change the phase here, similar thing would happen from 0 to 2 pi. I'll make it faster. So this is phase difference 0. At pi by 2, it becomes symmetric. And again from pi by 2 to pi, it goes to reverse of phase difference 0. .14, the change in the direction. Let's observe this motion anti-clockwise, t equal to 0. Observe the x and y positions where it would have been if the individual oscillator was there, and observe the trace, the combined motion. So again it forms a closed path. Going back to 2 pi, so this is with 2 pi and this is with. Now let us look at the effect of changing the frequency itself. Let's start from 1. Let's start with some phase of the phase and then let's change the frequency. You can observe the frequency is 1.17. If the ratio is 1.17, then it doesn't form a closed figure. So with 1.5, it forms. It's approaching 2, so this is what we get at 2. So if it is 2.65, let us observe the motion. It starts here, but after the end of the time period, it would not come back to the same position, but it would go to some other position. Started here and it will end here. If I change further, this is 3, this is more than 3, it's approaching 4, five. So this is the effect of changing the frequency. So I hope you have enjoyed this colorful presentation of Lissageous figures with various special cases.